I have mentioned before to Professor Hosnagel because he made a new definition or tried to do a new definition of safety. His field is the healthcare field, but he discovered or he realized that there are many things regarding safety that can be applied to other fields. So we can say Professor Hosnagel didn't define safety as the absence of something. Instead, as you can see in the definition, he said that safety is a condition when the number of successful outcomes, here he defined everyday work, is as high as possible. It is the ability to succeed under changing conditions. So we are playing all the time with variability. If we continue with this, we can say that safety is defined by its presence. Something is successful, there is no harm, that's safety. So safety is defined by its presence, and that leads to the need to understand everyday performance. And with everyday performance, Professor Hosnagel meant to understand how people adapt to different conditions. And let's say, think of a plane that is traveling from point Alpha to point Bravo. And during the trip, they have huge turbulences. They have to adapt to that. Many planes suffer that. So the pilots adapt to that. Or, for example, two planes that go to another place, they have another problems like running out of fuel because for some reason they started the trip with low fuel, things like that. There, the pilots and the ATM controllers are going to be adapting to the situations. And we have things like that in air traffic transport every single day. Also, if we go to nuclear sector, we will have a lot of valves leaking, sometimes pumps will fail, things like that. And nuclear workers are always aware and ready to change things. So that's the everyday performance. We can say also that the level of safety increases, and that means that the proxy measure should increase. So under this definition, safety can only be improved by situations where it is present. This is a little bit different than safety 1 analysis. We can call safety 1 also conventional safety or traditional safety. Now let's compare with the bimodal mode. And we can do again the question why things go right. And here we say that safety 2 comes from the success of performance variability in the everyday work. That means that it is based on everyday performance carried out by everybody. And from here, we will have both success and failure. So things will go right or wrong based on the different outcomes. Like this, success or acceptable things and failure, unacceptable things, are going to be variable. And we have to try to focus on everyday work, trying to see what things, small things, but frequent, are going to help us to improve in the future. So we can say that it is based on performance variability. The foundations of safety 2 is that the performance adjustments are ubiquitous and that the performance, therefore, is always variable. Also, this is going to lead to analyze the human contribution. Humans can do positive adjustments more times than negative ones. So here it's also important to try to focus on all those positive outcomes. The idea is that the variability shouldn't, however, be interpreted negatively. According to Safety 1, we have a lot of variable situations, but all of them, once again, have negative vocabulary, like performance deviations, violations, or non-compliance. On the contrary, the ability to make performance adjustments is an essential human contribution to work, without which only the most trivial activity would not be possible. Also, Safety 1 assumes that the causes are real, and the purpose of an accident investigation is to trace the development of that accident backwards, from the observable outcome to the efficient cause. In the case of an emergency, the observed final outcomes are also observable. That means they are real. But the same is not always necessarily true for what brought them about. What we mean here? The outcomes, for instance, may be due to transient phenomena or conditions that only existed during a given time in space and time. So it is not always easy to trace them back. These conditions may in turn have emerged from other transient phenomena. So the causes are thus reconstructed or inferred rather than found. They may therefore be impossible to eliminate or contain in the usual manner. But it may still be possible to control the conditions that brought them into existence, provided we understand how work is normally done. So here we can see a little difference between Safety 1, tracing back everything backwards, and that Safety 2, what it's going to do is looking at everyday work and analyze that everyday work, trying to anticipate and to learn, because Safety 2 is based on resilience.